All right, today we're going to talk about adding and subtracting rational expressions, section 8.3. Again, similar properties of adding and subtracting fractions. So for example, let's say, I had the fraction 1/2, and I'm going to say, let's add that to 3/10. Well, 1/2 plus 3/10, how would I add those fractions? I have to find a common denominator. So for instance, what would I have to do in the left fraction? Multiply by 5 over 5, right? And that gives me 5/10. And now I add them. When I add the numerators. That ends up getting me 8 over 10. Okay, when I'm adding and subtracting fractions, I have to have a common denominator, and then that denominator stays. Thank you. So, very same process today. The only difference is we're going to be looking at it from a little bit tougher problems. For instance, something like this. Alright, you can use the common denominator to add or subtract rational expressions. So we're looking at problems right here. I want to add 6x plus 4 over x plus 5 plus 2x minus 8 over x plus 5. Do we see the denominators here? Are the denominators the same? Yes. So the denominators are the same, so I'm going to look to add my numerators. What's 6x plus 2x going to get me? 8x. 8x. What's 4 plus negative 8 get me?
Negative 4.
So I get 8x minus 4 over x plus 5. And I'm combining like terms in the numerator. Okay. Same thing here as subtraction. Notice subtraction. 4x minus 3 over 2x minus 1 minus 8x plus 2 over 2x minus 1. Are my denominators the same? Denominators are the same, so I'm going to subtract my numerators. So what's 4x minus 8x? Negative 4x. Negative 3 minus 2. Does everybody see where that minus 2 comes from? Right here, right there, I have that minus sign. So negative 3 minus 2, what's that give me? So I get negative 4x minus 5 over 2x minus 1. And again, I'm still going to state where my x values are undefined. Basically, again, where is it always going to be undefined? What cannot be in the denominator?
Negative.
No, negatives. Well, 0. Okay. What cannot be in the denominator, though? What number? 0. 0 cannot be in the denominator, so we get undefined then. So let's look at a couple problems here, like number 1. I have x minus 5 over x squared minus 4 plus 3x plus 2 over x squared minus 4. Notice, are my denominators the same?
Yes.
The denominators are the same. Awesome. So I'm going to look to combine like terms in my numerator. So what's x plus 3x going to give me?
4x.
4x. Negative 5 plus 2? All over x squared minus 4. Now, can I factor x squared minus 4? I can factor x squared minus 4. What does x squared minus 4 factor to? 2 and? So I get x plus 2. X minus 2. Now, why do I want to factor? Because then I can find what x cannot equal. So, for instance, what can x not equal then? Negative 2 and 2. Nice job, Dennis. Again, basically, it's like saying each of these terms down here equals 0, because they can't equal 0. So you get negative 2 and 2. So my answer is all of that right there. Number 2, I'm going to subtract. 7x minus 5 over x plus 3 minus 4x minus 1 over x plus 3. Okay, so I want to look to subtract here. Are my denominators the same? Yes, so I'm going to combine like terms. So what's 7x minus 4x going to get me? 3x. What's negative 5 minus a negative 1? Negative 5 minus a negative 1 gets me negative 4. All over x plus 3. And then I look at my denominator. What can x not equal here?
Equal negative 3.
X cannot equal negative 3. Again, why is it negative 3? Because negative 3 plus 3 is 0 in the denominator. Can't get 0 in the denominator. Nice job. 3. Let's look here. Are my denominators the same? Yes, they are. So I'm going to look to combine like terms in my numerator. What's 2x minus 5x? Negative 3x. What's negative 1 minus 4? So negative 3x minus 5 all over x minus 1. And what can x not equal? 1. There's your answer right there. Take a couple seconds, try these 3 on your own. All right, number 4. Oh, I don't know. Let's go with Hannah here. Help me out here, Hannah. Hannah, are the denominators the same?
Why me?
Hannah, are the denominators the same?
Sure.
They are. Both are 3x plus 7. Denominator now, Hannah. Let's combine like terms. What's 4x minus x, Hannah? 3x. What's 1 plus 9, Hannah? So I get 3x plus 10. All over 3x plus 7. Awesome. Now I look at that. I got to find what x cannot equal. Who thinks I figured out what x cannot equal? This is kind of a tougher one. X cannot equal what here? What'd you say? It's not negative 3. What would give me a 0 here? Joe? You say negative 7? Ooh, close. No. Jake? Katie? Okay, let's think about it this way. What cannot be 0? The denominator, right? Does everybody agree the denominator cannot be 0?
Yes.
Okay. So basically it's like saying 3x plus 7 cannot equal 0. Does everybody agree with that? 3x plus 7 cannot equal 0. So if I were to solve for x here, what would you do? Wouldn't you subtract 7 and then divide by 3? So what do you get x cannot equal? Negative 7 over 3. Okay? So it's basically like setting it equal to 0, but you're going to set it equal to not 0. So you just say it cannot equal 0, and then you just solve for that x. Think about it. It's the same thing if I were to do like x plus 2. If I were to have x plus 2 in the denominator, it's x plus 2 cannot equal 0. Well, what's your answer going to be? X cannot equal what? X cannot equal negative 2. All right? Same idea. You're saying if it's a tougher problem like that, just say, hey, the denominator can't equal 0 and solve from there. 5. Drew, are my denominators the same?
Yes.
All right, so let's work it out here. What's 8 minus 5?
3.
What's negative x minus a negative x?
It'd be negative 2x. No, it'd be
0. So you end up with x or 3 over x minus 3. And what can x not equal now, Drew?
X cannot equal
X cannot equal a positive 3. Nice job. 6. 5x plus 2 over x squared minus 1 minus 3x minus 7 over x squared minus 1. Okay, are my denominators the same here? Yes, they are. Kyle, help me out here. What's 5x minus 3x?
2x.
What's 2 minus a negative 7? So we got 2x plus 9 over. I want to factor down the denominator. X squared minus 1, how does that factor out as? X minus 1, x plus 1. Awesome. So now I'm going to say x can equal what, Kyle? Yep, x can equal 1 and negative 1. And there's your answers right there. Nice job. So the denominator is the same. It's pretty easy, right? Just combining like terms, that's great. But what happens if the denominator is not the same? So I get a problem like this here. And I want to add x minus 4 over x squared plus 2x minus 3 plus 2x over x minus 1. Does everybody see this denominator right here? I'm going to want to factor this out. Because look what happens. When I factor x squared plus 2x minus 3, when I factor it, what do I get? X plus 3x minus 1. Does everybody see that? So what do both of these fractions have in common? An x minus 1, right? So what do I need to multiply the right fraction by? I need to take the right fraction by x plus 3. So if you notice here, I multiply the right fraction by x plus 3 over x plus 3. I would distribute the numerator, and that's where I get this expression right here. Now I have common denominators, and I can combine like terms to get my final answer. So this is a little bit tougher, yes. But again, it's very similar to if I were to take the problem 1/2 and say I'm going to add that to 3/10. I need to multiply the numerator and denominator by what they're lacking. Okay, same idea. So let's try number 7 here. Go through this slowly. I have x minus 1 over x squared minus 4 plus 3x over x plus 2. Notice my denominators not the same. First thing they did was they factored the left one there. Difference of squareds, it was x squared minus 4. I get x plus 2, x minus 2. Is everybody good with how we get x plus 2, x minus 2 there? Okay, now I'm going to look at it. What do they both have in common? They both have an x plus 2 in common. So what am I going to multiply the right fraction by? What's the right fraction missing?
X minus 2 over x minus 2.
So I'm going to multiply it by x minus 2 over x minus 2. Is everybody good with what I've done there so far? And then I'm going to distribute. So I get x minus 1 over x plus 2, x minus 2, plus 3x squared minus 6x over x plus 2, x minus 2. Does everybody see where I get the 3x squared minus 6x? That comes from distributing. And now I'm just going to combine like terms. See my denominators, they're all the same now? So now I'm going to combine like terms. There's no other 3x squared term, so I'm going to get 3x squared. I get x plus negative 6x. What's x plus negative 6x? Anybody? X plus negative 6x? Negative 5x. And then there's no other constant, so it's just minus 1. All over x plus 2, x minus 2. And there's your answer right there. And then if I look at my denominator, I'd say x can equal what two values? X can equal negative 2 and 2. Very good. 8. 4x minus 1 over x squared plus 3x plus 2 plus 3 over x plus 1. Does everybody see my denominator over here? What am I going to want to do here? I'm going to want to starts with an F. Factor. So I factor it. So that gives me 4x minus 1 all over. What multiplies to get 2 and adds to get 3? So I get x plus 2, x plus 1. Plus 3 over x plus 1. Now, what am I going to need to multiply each fraction by here? What am I going to have to multiply the right fraction by? What are they missing? It's missing an x plus 2. Does everybody see? It's an x plus 1 and x plus 1, right? It's missing an x plus 2. So I need to multiply this fraction by x plus 2 over x plus 2. Now I have common denominators. When I multiply, I distribute here. So I have 4x minus 1 over x plus 2, x plus 1, plus 3x plus 6 all over x plus 2, x plus 1. Does everybody see where I get the 3x plus 6? That comes from distributing the 3. And now I combine like terms. What's 4x plus 3x? 7x. Negative 1 plus 6? 5. So it's 7x plus 5 all over. My denominators are going to stay the same. X plus 2, x plus 1. And I'm going to state x cannot equal what values here? What can x not equal? Negative 2 and negative 1. Nice job. There's your answer right there. Okay? Do you see how these problems are a little bit tougher? Because we do need to do some work to find a common denominator. All right, again, it all comes back to understanding how do you add or subtract fractions. Have to have that common denominator. Okay? Take some time and try these 4 on your own. I would like you to do number 10 last. So do number 10 last. But take a couple seconds to try these 4 on your own. All right, number 9. What's good about number 9? We like this problem. Common denominators. Hannah, what's my answer number 9?
6x plus 8 over x minus 4.
Nice job. 6x plus 8 over x minus 4. I'm going to skip 10. We'll do that last. 11. Notice on number 11, you'd want to factor the denominator on the left side first here. When I factor that, I get x minus 4 and x plus 1. So Jake O'Connor, what do I need to multiply the right fraction by?
X plus 1.
So I multiply by x plus 1 over x plus 1. When I do that, I end up with x over x minus 4, x plus 1, plus 3x plus 3 over x minus 4, x plus 1, right, Jake? And then what's my answer going to be, Jake?
4x plus 3 over x minus 4, x plus 1.
4x plus 3 over x minus 4, x plus 1. Nice job, Jake. And 12, I need to factor the left one down. Katie, how do you factor x squared minus 1? X minus 1, x plus 1. So Katie, what do I need to multiply the right fraction by then?
X minus 1.
I need to multiply by x minus 1 over x minus 1. When I do that, I get x over x minus 1, x plus 1, minus 2x minus 2, all over x plus 1, x minus 1. Okay, what did you find out for our final answer then?
Cannot equal negative 1.
Oh, sorry, after you combine like terms.
Is it
Negative x plus 2, nice job. Making sure you distribute that negative, nice job. So negative x plus 2 all over x plus 1, x minus 1. And yeah, x cannot equal 1 or negative 1. Good work. And the last problem here, 10. I said save 10 for last. Because what you notice here, are my denominators the same? No. A lot of people look at this and they go, hey, see the right one? I can just add 2. Well, I can just add 2 to the left side and it's going to be the same thing. However, that's not how that works. Think about if I had the fraction like 1/10. If I had the fraction 1/10, and if I add 2 to both the numerator and the denominator, now I get the fraction 3/12. We all know 1/10 and 3/12 are 2 different fractions, right? That's not the same thing. Okay? So, they have different denominators. Think of a problem like this, though. What if I gave you the fraction 1/2 plus 1/3? And I said find a common denominator there. What would you multiply both of these by? You'd multiply the left fraction by 3, and you multiply the right fraction by 2, weren't you? Notice how I had to multiply both fractions? So in a problem like 10, what am I going to have to multiply the right fraction by? I'm going to multiply by x over x. And on the left side, what am I going to multiply the left fraction by?
X plus 2.
Yeah, I multiply the left fraction by x plus 2 over x plus 2. And now when I do that, I end up with 6x plus 12 over x, parentheses, x plus 2, minus 2x squared, all over x, parentheses, x plus 2. Now I look to combine like terms. My denominators are the same. I end up with negative 2x squared plus 6x plus 12 all over x parentheses x plus 2. And there's your answer. So again, a problem like 10 is quite a bit tougher. All right?
All good.
Yeah, that's it. The assignment comes up, I'll stop there. Here's your assignment.